Hello, it's been quite a while here. My name is Ololi Godwin and welcome back to Emoji Economics. For those that have been following on this channel, kudos to you all, kudos, thumbs up, that's very good. And if you're a new member on this channel, please make sure you like this video if you enjoyed it. Don't like it if you don't enjoy it. So if you enjoyed this video, please like it, comment, leave any questions behind, subscribe to this channel and turn on notifications to get more classes. Anyway, today we're talking about Cramer's rule. We are still talking about matrices and everything about it. So we've spoken about, I think it should be, I don't know, or maybe the 8th class or so on matrices. We've spoken about introduction to matrices, how to find determinants, then went to cofactors, minors, and all of those things. And we've also solved inverse of a matrix. Okay, we went through how to, go through inverse of a matrix, how to solve them, and what have you. So today we're talking about Cramer's rule. Now the thing is, basically, I don't know why lecturers or textbooks tend to disturb us with using inverse rule to solve a system of simultaneous equations when Cramer's rule is kind of a shorter way. So we could just use Cramer's rule and in about a few minutes we are done with what we want to do. But then there are times when we just have to know these things, just know the inverse method and other long things just because we want to know them. And I hope in the future that we might really get to know why we really have to stress ourselves into using these very long methods and techniques of solving problems when we have shorter ways. In real life anyway, do we necessarily go through long processes to arrive at answers? I think we basically look for the easiest way possible. Anyway, that's that about that. That's the difference between real life, reality, and what we do in theory and academics, in books, and what have you. So today we'll be talking about Cramer's rule, as I mentioned earlier. So Cramer's rule is a way of using determinants to solve a system of linear equations. Now, simultaneous equations could be solved using various means. Okay, you could use substitution method, elimination method. You could use graphical method as well. Then you could use matrices. Then you could make use of inverse method to solve a system of simultaneous equation, and you could use the Cramer's rule as well. I think you can't use inverse method to solve two simultaneous equations, yes, because you make use of minors, and along the way, I think there's going to be a problem or so in trying to get the minors. And anyway, that's about that. So let's just get to today's business. So we have an exercise on the board which says 2x1 plus 6x equals 22, and minus x1 plus 5x equals 53. Just as when we're talking about inverse, using the inverse method, when we're talking about matrix inversion, that students need to take notes of the positions of the variables. Now there is x1 here, 2x1, and just make sure that the corresponding variable we have here is x1. There is 6x2 and make sure that the corresponding variable that we have below it is x2. Now there are times when they get mixed, and because students are not that careful, you just want to solve and get an answer, so you don't look at what you're really doing. So sometimes x2 could be here when x1 is here, so you could have 2x1 plus 6x2, then have 5x2, then minus x1 here. So the variables get interchanged. Now people that are careful enough will know that they have to rearrange the other equation in order to be positioned the way the first equation is, and then you start to solve whenever you want to use the matrix method. But some people don't just remember, they just start solving and what have you. So what we have to do here is we break these equations into matrix form. So we have the coefficients matrix. So here this is 2, right? So we have 2, we have 6. This is minus x1, so its coefficient is minus 1, and this is 5. Okay, so we then have the solution vector, which is we have x1 first, and then x2 comes next. So that's the arrangement. Now here, that is how I was saying that make sure that you check the positions here, because if it were x2 here and this is x1, whereas here you have x1 and x2, your arrangement here is going to be wrong. Now how did I just get this? Now let's do matrix multiplication. 2 times this is going to give us 2x1, right? Then plus 6 times x2 will give us 6x2. So we have this guy back. Oh my, 6x2. So we have this guy back. Then equals, we have the coefficient. Okay, we have the vector of constant terms. So this is 22 and this is 53. So 53. Okay, so it's more like this times this plus this times this equals 22, so we have 22 here. Then we have minus 1 times x1 is going to give us minus x1, plus 5 times x2 will give us 5x2, and equals 53. Okay, so the first thing that we do is, this is matrix A. So matrix, you say this is matrix A, right? So 2 minus 1, 6, and 5. So we have to look for the determinant of matrix A, and the determinant is going to be, that shouldn't be a problem now. 2 multiplied by 5, 2 into bracket 5. I'm not going to write this, but I'll write it anyway. Minus 1 times 6, minus 1 multiplied by 6. So this is 10, minus times minus is plus 6, and that's going to give us 16. So the determinant is 16. Now what we have to do is, for us to get x1, so we are going to eliminate this column and then replace it by what is here, by this. So what we just have is, so I'll call that matrix A x1, right? And that will be 22, 53 here, and then 6, 5. So we leave what is here, we leave it here. So that's just how it goes. Then determinant of AX1, that's 16, right? Yeah, I think so. Where is it? Okay, that's 16. Cool. So we are going to be having 22 times 5, 22 multiplied by 5, minus 53 multiplied by 6, 53 multiplied by 6. So yeah, this is 110, 110 minus 318 or something. Okay, 318. So then we have minus 208. So that's the determinant of x1. So how do we get x1? So x1 is simply the determinant of ax1 divided by the determinant of a. I will be having minus 208 divided by 16, and this should give us is it 13? Okay, this should give us minus 13. So this is minus 13. So x1 is minus 13. We need to set it for x2. Now x2 is second here, so we are going to eliminate this column and then replace it by this. So what you have to do is, you have to be careful here, because you have to return to the original matrix. This is the original matrix, right? So we have our matrix, this is ax2 here, right? So this is, we have 2 minus 1, which is still there, 2 minus 1. This is where x2 is basically, because if you look at it, 2 times x1 plus 6 times x2, so this is x2, 6x2, 5x2, so we take 6, 5 away, then we replace with 22 and 53. What we did initially here was take 2 and minus 1 away, the coefficient of x1, and we replace them with this, you get, so there's no point in cramming anything there. So we have 2 minus 1, then we bring these guys, we bring them inside this place, so we have 22 and then 53. 53. So how do we get the determinant? So the determinant of ax2 is going to be equal to 2 multiplied by 53, alright, then minus 1 multiplied by 22. So this is going to give us 106 plus 22, and then we have 128. So x2 is then going to be determinant of ax2 divided by determinant of what? A, which is 128, right? Divided by, I think we got a minus. The determinant was, where is it? Tell me, 16, right? Is it 16? Okay, 16. Okay, and that gives us 8. So now we are done with solving everything. So x1, we just say x1, the coordinates is going to be, x1 was minus 13, and then x2 is 8. So that's all. You see, it's not long. So that's all. It's as simple as ABC. Now this is talking about a 2 by 2 matrix. Yeah. So let's move into using Cramer's rule, applying Cramer's rule to solve a 3 by 3 matrix. That is a 3 simultaneous equation. Okay. So then let me call that the second exercise 2. So we're dealing with something different here. So we're having 5x1, let me fast with it, minus 2x2 plus 3x3 equals 16, then 2x1 plus 3x2 minus 5x3 equals 2, 4x1 minus 5x2 plus 6x3 equals 7. Alright, so this is the system. So what we have to do is rearrange it in matrix form first. So check the position of the variables x1, x2, x2, x3, x3, then we have the constant. So I don't think that should be difficult now. So we just have the matrix being 5, okay, the coefficients matrix being this, minus 2, please make sure that you don't write 2 instead of -2. And this is -5, this is 3, -5, and this is 6. Okay, then we write the solution vector x1, x2, x3, and then write the vector of constant terms 16, 2, and 7. So what you have to do is we apply the whole thing again. So we call this is our matrix A, right? Kx and whatever it is you want to call it. Now the determinant of A, remember what we used to do. So this is going to be a plus, minus, plus, right? So we have 5 into bracket. Take this row out, this column out, and this. So we're having 3 multiplied by 6. Okay, so we have 18. Minus 5 times -5, that's 25. So you have that like that. Then minus 2, that's going to give us a +2 into bracket. We take this column out and this row out. So we have 2 times 6 is 12. Minus 4 times -5, that's -20. Minus 20. Then we are left with 3 plus 3 into bracket. So we take this guy out, 2 times -5 is -10. So we have -10. Minus 4 times 3 is 12. So we have 12 here, right? So this is 5 into bracket -7 plus 2 into bracket. This is 32. Then plus 3 into bracket -22. So when we are done, this is -35 plus 60. Is that 64? So let me check because okay, 64 minus 66, and everything gives us -37. So that's the determinant of A. So we have to look for AX1, determinant of AX1, AX2, and AX3. Back to business. For us to find AX1, so AX1, matrix AX1 is then going to be, since what we are looking for is X1, so we eliminate the column of X1 and replace it by the constants. We have 16, 2, 7, 16, 2, and 7. Then -2, -2, 3, and -5. Then 3, -5, and then 6. Alright, so we have plus, minus, plus. So determinant then is determinant of AX1 is going to be 16 into bracket. This eliminates this. 3 times 6 is 18. -5 times -5 is 25. So we are done with that. And minus 6 is going to give us +2 into bracket. So it's so simple, right? This goes and this goes. So we have 2 times 6 is 12. Then minus 7 times -5 is -35. Okay. Then we have +3 into bracket. This takes away this. So we're left 2 times -5 is -10. Then -10 minus 21. Okay. So this gives us 16 into bracket -7 plus 2 into bracket. 12 minus 35 is 12 plus 35, that's 47. 47, then plus 3 into bracket minus 31. Please make sure that you are using your calculators to verify what I'm doing on the board. Now 16 times -7, so I think I need to check this right now. That's going to give us -112. This is -112 plus 94. Then this is -93. Okay. Is that so? Yes. So 94 minus 93, that's 1. Then -112 plus 1, that's -111. Okay, so this is going to give us -111. So how do we find x1? x1 is going to be determinant of AX1 divided by determinant of what? A, and that's -111 divided by -37 that we got there. Okay, and this gives us 3. So that's all. So instead of using the inverse method where you have to find minor, cofactor, transpose it, get the adjoint, then you find, it's terribly long. Alright, so for us to get x2, so matrix AX2 is then going to be, so we replace what we removed here. So we have the original 1, 5, 2, and 4. 5, 2, and 4. Since we are looking for x2 now, so we eliminate the coefficient of x2 here and replace it with 16 to 7. So we have 16 to 7, and then we are left with 3 minus 5 and 6. 3 minus 5 and 6. Okay, so this plus minus plus. So the determinant of this is going to be, so let me say the determinant of this will then be 5 into brackets 2 times 6 is 12 minus 7 times minus 5 is minus 35, right? Then we have, this is minus on this guy, so minus 16 into brackets, okay? 2 times 6, 12, 12 minus 4 times minus 5 is minus 20, okay? Then this is plus, right? So plus 3, okay, can I contain it? Let's try. Plus 3 into brackets. This takes this. 2 times 7 is 14. 14, right? Minus 4 times 2 is 8. Okay, it contains it. Alright, so there we go. Now, determinant of A, so just continue here. Determinant of A is going to be 5 into brackets. 12 minus minus 35, that's 47. Then minus 16 into brackets. 12 minus minus 20, that's 32. That's 12 plus 20, 32. Then plus 3 into bracket 6. So 5 times 47 is that 235? 235. So you have 235 minus 512 plus 18 basically. Let me check to verify. 235 minus 512 plus 18. So we have minus 259 at the end of the day. So for us to get x2, so that will be it is important to write the formulas because they carry their respective marks. Okay, don't say because the question is too simple and then you skip some steps and lose marks unnecessarily. Now this is going to give us minus 259 divided by minus 37. At the end of the day we're having 7. So x2 is 7. So how do we get x3? So we have to look matrix AX3 now. Will be, so we have every other thing. So we have this there, this in the new matrix, this will be there, but this won't be there. The coefficient of x3 would be replaced by the constant terms. So you have 5, 2, 4, minus 2, 3, minus 5, then 16, 2, and 7. Alright, so determinants here, determinant of x3, AX3 is going to be, okay, this plus, this minus, and then this plus. So we have 5, that's plus 5 into brackets. 3 times 7 is 21 minus 5 times 2 is minus 10. So we have minus 10. Okay. So that's closed. Then minus 2 is going to give us plus 2 into brackets. This cancels this. 2 times 7 is 14 minus 4 times 2 is 8, right? Then we have plus 16. We have plus 16 here. This column takes away this row. So we have 2 times minus 5 minus 10 minus 4 times 3 is 12. Okay, so we proceed here. So determinant of AX3 is going to be 5 into bracket. 21 minus minus 10 is 31. 31 plus 2 into bracket. 14 minus 8 is 6 plus 16 into bracket minus 22. Okay, 5 times 31 is going to give us 105 plus 12, and plus times minus of course is going to be minus. Then 22 times 16, I think we did that earlier. 22 times 16 is going to give us 352, but because they minus, so we have minus 352. So everything here gives us minus 185. Alright, so that's the determinant of AX3. So x3 on its own now is going to be the determinant of AX3, right? Divided by the determinant of A, and that's going to be minus 185 divided by minus 37, which is still over there, and the answer is 5. So x1, x2, and x3 is going to be equal to, so we got 3, 5, and 7. So 3, 5, and 7 respectively. So that's about Cramer's rule. That's not about it. So it's not a big, it's not big at all. Now I'm going to give you an assignment, okay, which is my usual norm these days. So the assignment is just going to be for you to use the Cramer's rule to solve a system of linear equations. So here, let me just drop this off. So this is going to be the assignment. So leave your answers in the comment section. Okay, I believe you can solve wherever you want to solve. Make sure you solve it because I believe many of you can use calculators to solve this. but you won't be deceiving me, right? So I know how to solve it. So you really have to know how to solve it. Although in the real world, you may not have to solve anything here. Once you know a calculator that can do it, or a computer that can do it, or Excel or whatever, just pointing the stuff there, and we should deal with bigger problems really, not the ones that computers can already solve. Alright, so assignment, but for academic purpose, please know how to do this. Assignment, so this is going to be 2, 4, minus 3. So this is 2 plus 4, then this is minus 3, and then what we have here is 52. Okay, then this is minus x1 plus 5x2, then plus 3x3 plus 3x3 equals 72, or 72. Then here I have minus 3x1, right? Then plus I have 2x3 here, 2x3. Okay, then I have minus 7x2 over here equals 10. So let me cross check it. 2x1 plus 4x2 minus x3, so it's good to cross check. 2x1 plus 4x2 minus x3 is 52, minus x1 plus 5x2 plus 3x3 is 72, and minus 3x1 plus 2x3 minus 7x2 equals 10. So that's the assignment. What you just have to do is to make sure that you use the Cramer's rule to solve this system, and then leave your answers in the comment section. If there's any question that you have, please leave them in the comment section, and if you want to comment us for the work that we do, leave them in the comment section as well. That's how we know, or one of the ways we know that you love us. If you enjoyed this video, please, that like button doesn't bite, right? So click on the like button, then click on the subscribe button as well if you haven't done that. The notification bell shows, then you click on that notification bell, and that tells you when new classes are made available. You can share this channel with your friends. You just found a wonderful channel, right? You share it with your friends and colleagues and let them understand economics better. Okay, so in our next class, we'll be talking about Cramer's rule still, but then we'll be dealing with how we use Cramer's rule in economic applications. We'll be maximizing a profit function. It's right here in my notes. Alright, so that's the video I'm going to do immediately after this anyway. So we'll be maximizing a profit function, and you have to click on that notification bell to get notified when that class is made available. See you in the next class. Thank you.